Hello everyone, this is Pratika. I'm gonna teach solutions chapter 1 of second PUC chemistry. Okay, let's begin. Before going to the definition of solution, we shall see the uh, definition of pure substance. Pure substance is a form of matter that has fixed chemical composition and characteristic properties. For example, copper, zinc, nickel are pure substance. Mixture of these pure substance gives a composition of a substance like brass, German silver, bronze. Like brass is a mixture of copper and zinc. German silver is a mixture of copper, zinc, and nickel. Bronze is a mixture of copper and tin. Now, types of solutions: homogeneous solutions and heterogeneous solutions. Here we focus on homogeneous solutions because in the definition of a solution, solutions are a homogeneous mixture of one or two compounds or pure substance. Okay, in homogeneous mixture, component in a large quantity is solvent, and one or more component present in the solution other than the solvent is a solute. So one or more component in a large quantity is a solvent, and one or more component present in the solution other than the solvent is called solute. Solvent describes the physical state in which solution exists. One or more components present in the solution other than the solvent are called as solutes. In this unit, we shall consider only binary solutions. What is binary solutions? Consisting of two components. Here, each component may be solid, liquid, or gaseous state. Consisting of two components, that is solid, maybe solid, liquid, or gaseous state. For this example is given in the textbook that in gaseous state, gas, if solute is gas and solvent is gas, mixture of oxygen and nitrogen gas is a example. And likewise for liquid gas, solid gas, liquid, liquid in liquid state is also given in the textbook. You can refer it. There are several ways to express the what composition of a solution can be described by expressing its concentration. The latter can be expressed either qualitatively or quantitatively. For example, qualitatively we can say that solution is either dilute or it is concentrated. That is qualitatively. Qualitatively we can say that the solution is dilute or concentrated. But in real life, these kinds of descriptions can add to the lot of confusion, and thus the need for the quantitative description of the solution is necessary. Qualitatively, we can say that whether it is what concentrated or diluted. Quantitatively, we can describe the solution. There are several ways by which we can describe the concentration of the solution. First way is mass percentage. Mass percentage is represented as MP. It is not a representation thing. I am giving the name as MP. Uh, MP, mass percentage, is equal to mass of the component in the solution divided by total mass of the solution into 100. Why into 100? Because we have to convert mass into percentage. Percentage means 100. So mass percentage is equal to mass of the component in the solution divided by total mass of the solution. I'll give one example. Okay, let's go for next one. Volume percentage. Uh, volume percentage. VP. Volume percentage of a component. Volume percentage of a component is equal to volume of the component. Volume of the component divided by total volume of solution into 100. Why 100? Because we want in percentage. Okay. Okay, mole fraction. Mole fraction is a number of moles of the component divided by total number of moles of the component. Okay. Example I'll give one by one. In the textbook, there's one question. Calculate the mole fraction of ethylene glycol, that is C2H6O2, in a solution containing 20% of C2H6O2 by mass. How will you find out? Here they have given the solution as, assume that we have 100 gram of solution. For 100 we are taking 100 gram of solution. Wait. We have 100 gram of solution we have to assume. One can start with any amount of solution because the result obtained will be same. You can start with 1000, 100, anything. Solution will be contain 20 gram of ethyl glycol. Why 20 gram? In 100, 20% means 20 gram, right? So, see, I'll show you. 20% means what? 20 by 100 into 100. 100 cancels, gives 20 gram. So ethylene C2H6O2 is about 20 gram. C2H6O2. Now, if 20 gram is C2H6O2, then what is the remaining 80 gram? That is water, H2O. Okay. Now, molar mass of C2H6O2 we have to find out. What? Molar mass of C2H6O2. Then, how will you find? First of all, you have to find the molar mass. Then each moles of C2H6O2, then H2O, both. We have to find out. Then put it into the formula. That's it. I'll show you. Molarity, molar mass of C2H6O2 is 20 gram. It is 20 gram, right? 20 gram Sorry, we are finding molar mass, not moles. So C2 means what? C is 6. 6 into 2, 12. Correct? Is atomic number. 6 into 2 plus 6 into 1 plus 8 into 2, which gives molar mass 12 plus 6 plus 16. 16, that is 18, 28, 29, 30, 31, 32, 33, 34. 34. 34. Oh, ugh. Sorry, I made a mistake. I took atomic number. We should take atomic mass number for molar mass. Okay? Don't make this mistake. This is wrong. Molar mass of C2H6O2 is equal to 12 into 2 plus 6 into 1. No. Yeah, 6 into 1 plus 16 into 2. 12 to the 24 plus 6 plus 32. That is 24 plus 6 is 30. 30, 62. Let's check. Yeah, 62 gram per mole. Inverse. Gram per mole. I'll say it is 62 gram per mole. Next step is to find the moles of C2H6O2 as well as moles of water. Then finding the mole fraction of ethylene glycol. That is by formula moles of C2H6O2 divided by moles of C2H6O2 plus moles of H2O. That's it, then over. Let's solve it. Okay, we saw 100 gram of what in question. Calculate the mole fraction of ethylene glycol C2H6O2 in a solution containing 20% of C2H6O2 by mass. So we have to find the mole fraction. To find the mole fraction, we have to assume that we are having 100 gram of what? Ethylene glycol solution. 100 gram of solution. In that 20% is ethylene glycol. That is 20 gram of 100 gram. So 20 gram is a C2H6O2. Then 80 gram is a water, that is H2. You have to find the molar mass of ethylene glycol. We have found it in the last slide. So molar mass is 62 gram per mole we got. Then mole of C2H6O2 is equal to, by the formula, number of mass of C2H6O2 divided by molar mass of C2H6O2. What we'll get, that is in a mole, that is 0.322 in mole. Then mole of H2O is same thing formula, what? A mass of water divided by what? Divided by 18 gram means its molar mass, water's molar mass. That is, we'll get 4.444 mole when we divide by calculator. Then how did we get 18? We got 18 by doing the 1 into 2. 1 is hydrogen and 2 is H2 plus 16 into 1. That is oxygen. 2 plus 16 is equal to 18. Mole fraction of ethylene glycol is formula is mole of C2H6O2, that is ethylene glycol divided by mole of ethylene glycol plus mole of H2O. We'll get 0.322 divided by 0.322 plus 4.443, which is equal to some answer you get by calculating in a calculator. You'll get as 0.932. 0.932 you'll get. It has no unit. Similarly, of a water you should find mole fraction of water. How will you find? What is the mole of water? That is 4.444 divided by mole of a water plus mole of a ethylene glycol. You'll get sorry. Mole fraction of ethylene glycol answer is 0.060. Okay. 0.068 and mole fraction of H2O is mole of water. Mole of H2O divided by mole of H2O plus mole of C2H6O2. C2H6O2. That gives what? 4.444 divided by mole of water 0.322 plus 4.444, which is equal to 0.932. 0.932. Over. That's all.